Hello viewers, Assalamu alaikum. Today I am going to show you how to do a project or design an antenna regarding how to design a dipole antenna 2.4 gigahertz. For doing this, we have to go to our CST Studio Suite 2019 and we are selecting this procedure, selecting the time domain, and here is the unit by default, and for the frequency minimum 1 to 10 gigahertz. Since 2.4 gigahertz is in between them, we are selecting E field, H field and far field. Define at 2.4 gigahertz, it is set to 5.5. we are changing this 2.4 gigahertz and clicking on to next. Here is the template name of my antenna design. We're selecting halfwave dipole antenna at 2.4 gigahertz and click on to finish. So after clicking finish, you will find an interface like this. So first of all, we have to set our parameter. There are several parameters for designing an halfwave dipole antenna. So here is the parameter list in the left corner. Since we are designing a wire antenna and here is the radius of the wire, generally we are setting the radius of the antenna is 1.5 millimeter. Since the radius of the antenna is in millimeter unit, and we are writing the description radius of antenna. Since we are designing a 2.4 gigahertz antenna, so for calculating the length of the antenna, we may calculate it from the macros. Click onto it, select calculate, and in the last there is calculate wavelength. So we'll set the frequency 2.4 and by default it is in the gigahertz range, and if we click OK, then what will be the length of the antenna, it may calculate it, and we found that for the half wavelength 62.46 millimeter. How does it calculate? It calculates generally from C equals to F lambda equation. Here C is the speed of light and F is 2.4 gigahertz, and we will find the wavelength lambda 62.46, and it is defined as length of the antenna 62.46 millimeter, and it is the length of the antenna. There is another parameter for an half wavelength antenna, that is the frequency 2.4 gigahertz and frequency of antenna. Now we are selecting the feed of the antenna. Feed gap means feed gap is 10. If we select it as 10 millimeter, the difference between the two antenna, and it is the feed of the antenna. And here is another parameter that is named impedance, and generally impedance is set to 73 ohm, and it is the impedance of the antenna, writing the description. Now we will model the antenna. For designing this, we will select the cylindrical and double click onto this, and again double click, and again we will double click it. Then we will find a cylinder, and we will press the ESC from the keyboard, and setting up you will find this option, and setting the name of this is dipole, and the outer radius of the antenna will be R, and no need to insert the inner radius. And there are several axes, that is the X, Y center, X center and Z. we are designing this antenna in the z-axis, so we have to keep x center and y center 0 and setting the length of the antenna, that is in the z direction there is minimum L by 2, negative L by 2 to L by 2, and selecting the material is perfect electric conductor. And if we click the preview button, we find that the antenna is ready for cylinder. Here is our designed antenna, designed cylinder. Now we will insert the feed. For designing feed, we will select again the cylinder and again double click into this interface, again double click, again double click, then press the ESC button from the keyboard, setting up the name is cylinder and outer radius will be R, and no need to insert the inner radius. And here is same for x center and y center will be 0. And what will be the z minimum? That will be the negative feed divided by 2, because it will go half portion in the negative axis in z direction and half portion to the positive axis of z direction, feed divided by 2. And what will be the material? It will be must a vacuum. And if we select the preview, that means it is inserted in the dipole, and clicking on to OK. Now select none to all and OK. Now for inserting the dipole feed into the dipole, click on to components and select the dipole and click boolean. Here is an insert option and select feed and hit the enter button. The feed will be inserted in the dipole section. So after inserting it, we have to do another work, that is we have to select the edge, and for this going to the peaks and select the edge. Now again peak, select peak edge and click onto this. The two edges are selected, and going to the simulation section, select the discrete board, and the impedance of the antenna is set to Z, that means 73 ohm. So click the preview button and OK. So our antenna is generally designed and set the parameter as it is. Now we'll clicking onto the start simulation. After several minutes you will find after the simulation we'll clicking onto the 1D result. There is the S parameter. Since we have designed a 2.4 gigahertz dipole antenna, so there the resonating condition should be in 2.4, but the resonance is happening between the 2.1 and 2.2. So there is a optimizing option by changing the length of the antenna. So we may try for setting or resonating at 2.4 gigahertz. Setting up the length of the antenna is 70 millimeter and store the result, current results, and OK, and we'll select the start simulation. After simulation we'll find that by the increasing of the length of the antenna, we'll find that the resonating condition is shifted to backward, that means it is in between 1.8 to 1.2. So by increasing the length of the antenna, the resonance point is not, we are not getting the resonance point. So we are again changing the length of the antenna below around 50 and store the current result and selecting OK. and start simulation. After giving the start simulation, after finishing this, we'll find that the resonance point is shifted to 2.6, above 2.6. So we're not getting the required resonating point. So what we'll do, we'll select the optimizer, and the length will be changed. The length will be minimum 50 to 70 because the resonance condition is in between the length 50 to 70. So minimum value of the length will be 50 and the maximum value of the length will be 70. Now clicking on to OK, and what will be the goal? The goal will be add new goal. Clicking on to add new goal, and magnitude in decibel, and operator move minimum. Target, the target of is 2.4 gigahertz, and here is the parameter. For this parameter we're selecting 2.4 gigahertz and click OK, and clicking on to the apply. And if we select the start, then the optimizing option is started. Here is the length given to 50, that means it will start from the 50 millimeter, and when it find the required length, the length is given 55 to 616, and in the image section we are watching that the resonating condition is in actually in 2.4 gigahertz. So what will be the length? The length will be 55.44 gigahertz. Here is the parameter list, and it is already given. So this is our experiment. We have designed a 2.4 gigahertz antenna, half-wave dipole antenna. So what we have to see in this resonance condition, the far field, there are several far field, and that is absolute, theta, phi, phi pitch, and different types of shapes are here given. Okay,